Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson. Yesterday we learned about the Pythagorean theorem, which as you can see is right here, a squared plus b squared equals c squared. Today we're going to learn about the distance formula. But before we do that, I want to ask you, how could you solve for c in this equation? Well, we did a couple days ago. We solved for x in equations like this. If we want to solve for c, we see that c is being squared. We are going to need to take the square root of c, or in this case the rad, where we're interested in the positive square root. And so if we do it to one side, we're going to have to do it to the other. Okay, and when we do that, we'll end up with c equaling the square root of the sum of the squares of a and b, right? Okay. Now in a minute we're gonna come back and talk about this, but I wanted you to see that. Hopefully that should seem real simple to you. All right. The distance formula is hidden over here. Let me uncover it for you. It's this big ugly thing right here. You may not believe me, but I know you'll trust me. This big ugly equation right here is the same thing as the Pythagorean theorem. Yeah, that's all it is. But you see the x sub 2 and x sub 1 and y sub 2 and y sub 1, those should strike you as the coordinates x and y. Now, we're going to see how to use it in a minute, but let me scroll on down here and take a look at this little coordinate system. And you see I have this, we're going to call it point A, and we're going to have this point B. Okay? We need to know how far apart points A and B are. We need to know that distance. Well, if you're thinking right triangles, some of you might begin to realize that, geez, if I know this distance here, and I know this distance here, I could make a right triangle and I could use the Pythagorean theorem to figure out how far apart they are. Now, let's check this out here. The distance, we're going to call this point C. The distance from A to C looks like it's 1, 2, 3, 4 units long. And notice that's in the x direction, isn't it? Okay, and the distance from B to C is 1, 2, 3 units, right? And if you recognize your Pythagorean triple, you'll know that the distance from A to B is 5. But in case you didn't recognize, let me take 3 squared plus 4 squared, and I'll set that equal to, oh, in this case, I'll call it x squared, because I don't know how long side AB is. Well, that's 9 plus 16 equals x squared, and I'll get 25 equals x squared. And I want to take the rad of both sides because I'm interested in the positive square root. And so when I do that, I get x is equal to 5. And I'm sure you already recognize that. But I want to point something out to you. Take a look at the coordinates of point B and the coordinates of point A. Look what happens if I subtract the y values. If I subtract the y values, I get 3, which was the distance in the vertical direction or the y direction of my right triangle. Yeah. And if I subtract the x values from each other, 6 minus 2, I get 4, which not coincidentally was the distance from A to C, or the distance of the right triangle in the x direction. So you see this, just the Pythagorean theorem. And if we go back up here and we look at this distance formula equation, the one in red, it says subtract the x's, square it, subtract the y's, square it, the difference that is, add them together, and then take the square root. That's what we did to figure out 5. So knowing that, we can now find the distance from any 2 points by using a special form of the Pythagorean theorem, the distance formula. And 8th graders, you're lucky this formula is on the formula sheet for the OAA. Let's say that A is 6 and B is, I don't know, -2. Oh, excuse me. A is at 6, -2. And then point B, its coordinates, is -5. And I'll make the Y coordinate, I don't know, 4. Okay. Well, to do the distance formula, okay, to set it up the way the textbook would have you do it, I'm going to say D is equal to the square root, and I'm going to subtract my x's. So I'm going to take 6 minus -5, which is 6 plus 5. At this point, I'm not going to show the minus negative. I expect you to be able to follow along with me. I'm going to subtract my y's. -2 minus 4. And I'm going to square it. Okay. By the way, when we did slope, it was really important to be consistent. You know, if you started with this coordinate, you had to start with that one and the other quantity. And the distance formula is not as important. I do it out of habit, and I think it's a good habit to have, but it is not super duper important. Okay, 6 plus 5 is 11. 11 squared, right? And most of you can see that 11 squared is going to be 121. Okay, and then I'm going to add -6 squared, which is going to be 36. So where am I at here? Running out of room, so I'll jump over here, and I'll have D is equal to the rad of, what are we at here? 157. 157. Okay. And hold on one second. And now normally to go for the exact answer, I have to break that down, but I know that rad 157 doesn't break down. It's simplified as far as it can go. Now, I do know that 144 is, the rad of 144 is 12, and I know the rad of 169 is 13. Now, if I think about it, let's see, 144 to 157, you read 157, right? Okay, that's 144, 157 is 13 spaces, right? And 157 to 169 is 12 spaces. So this is pretty close to being smack in the middle. It's just a hair under. I could guesstimate that the distance is about 12.45 or 12.48 or something like that. And let's see here. Hold on, let me clear that out. Oops. I'm in draw mode there. Sorry about that. Okay, so if I take the square root of 157, I'm going to get, 12.52. So of course, because I should have said a little bit more than 12 and a half. My mistake. I see it now. Sorry about that. The reason I say that is because the distance from 157 to 169 is smaller than the distance from 144 to 157. So therefore, the square root of 157, or the rad, has to be a little bit more than 12 and a half. So it's approximately 12 point, what did we say, 5.53. Okay, going to the nearest hundredths place. So 12.53. Okay, now I'm going to have you give both answers on the test on Friday. So there's your exact answer. And then you could say approximately 12.53. By the way, if you're having mistakes rounding, please come see me. Rounding is such a simple thing. I had a pre-algebra kid show me a trick that they use when they have something like 314.6258. And what they did was they put a 1 above the decimal point, and they put a series of zeros. And I know I've shown you this before, but some of you are still rounding incorrectly. And for honors algebra, it's not acceptable to be rounding wrong. You see how there's a 1, 0? That makes this the 10th place. This is 100, so that's the 100th place. Okay. And then so on. Thousandths, 10,000ths, etc. Okay, so if you're having mistakes rounding, please come see me. I'd love to straighten you out. It could probably take 5 or 10 minutes to do it, and you'll be fine. All right, let's try one more. Let's make point A have the coordinates -8, 3, and we'll make point B have the coordinates 5, -7. Okay, now you can use the straight distance formula. I want you to go ahead and pause the video and try this on your own because it's pretty simple. I'm actually going to do this one slightly different than the straight distance formula. I'm going to talk my way through the distance formula. Okay, so I know that the distance formula, oh, by the way, if you're watching now, you want to see my solution. The distance formula is this. Okay, but more basic, and I know some teachers get mad at me when I do this. And they're not math teachers, of course. I think it's because they don't understand the simplicity of the distance formula. So here's what I'm going to do. Okay, hopefully you have your answer now, and you'll see if I do this right. First of all, I'm going to subtract my x's. -8 minus 5 is -13. I need to square that number, okay, which will give me 169. All right, now I need to subtract my y's. I'm going to do this part. 3 minus -7 is 10. I need to square that, which is 100. I need to add them together. So now I'm on this part of the distance formula. So I subtracted my x's, squared it, subtracted my y's, squared it. And when I add that together, I'm going to get 269. Okay, now I'm going to take the rad, or the positive square root of 269. And that is the distance formula. That's what we should get. Now, of course, I'm going to have to see if this breaks down. So this is kind of a big one, but let's see here. Let's see if I can find any factors of 269. Remember, I've got my perfect squares. If I can find those factors, that would be the best. So 1, 4, 9, 16, 25, 36, 49. Where are we at? 7, so that'd be 8, 64, 81, 100, 121, 144. Ooh, that's gross. 169. Where are we at? 13, 14, 196, 225. Okay, and if it's 16, 256. And I don't need the list anymore. And I'm just going to go through and see if I can get any of these going. I know 256 isn't going to go even evenly. Cross that off. Well, I shouldn't cross it off. Maybe I should put an X by it. Okay, I'll do that. So I know that's not going to go in. 225 is not going to go in evenly. I know 196, 169 is not going to go evenly. 144 doubled is 288. That's not going to go in. 121 doubled would be what? 242. Another 121 would take me too high. I know 100 doesn't go in evenly. 81. Okay. 81. Well, I'm going to need it to end in 9. The only way to multiply 1 and get it to end in 9 is if I multiply by 9. If I multiply this by 9, I'm going to get 729. That's way too big. There's no way that's going to work. All right, so now I'm down to, that should say 64. It kind of looks like 68. Make sure we realize it's 64. Apologize, it's the airliner. 64. Can I multiply 4 by any number and get it to end in 9? I'm not coming up with any. 4, 8, 12, 16, 20. And then they start to repeat, so I know 49 is not going to work. All right, 36 isn't going to work. I'm starting to think that this guy is not going to break down. 36 is 6 times anything going to equal 9? I don't think so. 6, 12, 18, 24, 30, 36, 42. And see, they've started to recycle, so we're not going to get a 9. 5 times anything isn't going to end in 9. There's a 6 again. Well, 9 might possibly work. I guess I could try doing long division by 9. All right, 9 is going to go into 26. 2 times 18. All right. Oh, you know what I should really do instead of doing long division? I should use my trick. 2 plus 6 is 8, and 8 plus 9 is 17. And 9 does not go in 17. 9's not going to work. 4 is not going to work. There are no perfect squares that go into 269, so my distance formula answer is rad 269. Now, if I want to guesstimate it, I know 269 is between 256 and 289, right? You know, it's definitely closer to 256. It's only 13 away there. It's 20 away. So I'm going to guess that it's about 16.3 or 4, somewhere around there. Let's check it out. I got to take 269. Oops, I'm in draw mode. Let me get out of draw mode. All right, so I'm going to clear this. I want 269. I'll take the square root. And 16.4. So my estimation was pretty decent. I came up 16.3. I can use a calculator and go 16.40. Not a bad estimation. All right. So let me finish that. And I'm noticing the time on the video. I don't want this to go too long. So you've seen the distance formula in action. There's the exact answer, the rad 269, the approximate 16 4/10. All right, Mr. Lawrence signing off. Have a good night, everybody.